Hello, my name is Georgi Dimitrov and today I will be introducing you to my dissertation on firefighter temperature feedback. First, some background. Firefighters use a technique where they feel the temperature of a door they would open through their gloves before entering the room, so they would get the rough estimate if there is dangerous heat on the outside of the door. This is how they do it. This is a very crude method, and the gloves firefighters have are designed to insulate them from the heat, much like kitchen mittens, so they don't really have a good perception for the outside temperature. My solution to the problem is building on an existing project that found out that conventional pieces of kit just won't cope with the high temperatures experienced by firefighters. This is why I'm using a highly robust temperature probe, a K-type thermocouple, shown here. It measures temperatures and generates electric current which can be measured, but this current is very weak. This is why I'm using a cold junction amplifier, which is this, to amplify the signal and then transfer it to an embedded microcontroller, shown here. In the microcontroller, custom software takes the current measurements and converts them to Celsius temperature, then sends them via USB cable to a phone, which runs on Android. The Android phone contains custom software that senses when the embedded USB device is connected and automatically starts an application which starts to look for any low energy Bluetooth devices that might be nearby. The Bluetooth device that I'm using is a BLE Nano Kit from Red Bear Labs, which I'll show you more in detail later. Once a BLE device is selected, a new screen opens up which has a toggle switch for on and off. This switch controls the data transfer via the USB cable from the embed device. When it is turned on, it starts receiving data and outputs them to the screen, and also starts to transfer the data to the Bluetooth device. The Bluetooth device itself is a BLE Nano Kit that also contains custom software and is programmed using embed tools. It has a set of 3 different LED lights that can be triggered by changing the temperature of the probe. As you can see, there are some different stages for the LEDs. There are 4 stages total: green for safe, yellow for caution, red for dangerous, and 3 flashing lights for very dangerous, which I will show you now. We can see that the LEDs will start changing as the probe heats up. Another way to warn the user of any potential danger is through vibration. Unfortunately, the small Bluetooth board is just not powerful enough to power one of these, a vibration motor. This is why I'm using the phone's integrated vibration motor to warn the firefighters of any potential dangers. The operator would have the Bluetooth device and some batteries mounted in their face mask. The mask itself would not be connected to any other parts of the equipment which necessitated the use of wireless data transfer. The Bluetooth is mounted in such a way that it would not flash lights directly into the eyes of the firefighter, but produce ambient light that is visible in the dark. This does not obstruct the firefighter's vision, which is very important for them. The phone and the embed microcontroller would sit safely inside the firefighter's jacket, and the temperature probe itself would run through the sleeve of the jacket and exit at about the wrist. And this is how it would look. This is the probe itself, and the phone and the Bluetooth device. You can see the Bluetooth device blue light flashing, and the phone itself are safely stowed inside the firefighter's jacket.